Homework 4.3, Properties of Logarithms, Video 1. Homework due Friday, May 29th, 11:59 p.m. This video is associated with questions 1 through 3 directly in this homework and also indirectly with 10 through 19. In the previous video, we learned about logarithms. We learned that a logarithm is basically asking a question, what power turns the base into the argument. And we learned a lot of other things like some simple properties of logarithms. One of which was log base b of b is equal to 1 because 1 is the power that turns b into b. Another one looked like this, log base b of b to the n power equals, well, remember the question a log is asking you, what power turns the base into the argument? Or in this case, what power would you put on a b to turn it into b to the nth power? Well, the answer is that power. But I think we had about 6 properties. But in this video, we're going to learn 4 more properties of logarithms, which we will put directly into use in the next series of videos. The first property that we're going to talk about is called the product rule. I could get you to tell me the product rule with enough time and enough dialogue, but since this is a video and hence a monologue, I'm just going to tell you the product rule. The product rule for logarithms is a rule for a logarithm, any allowable base. Remember, the base has to be positive, but it can't be 1. But the argument is a product, a multiplication problem. So I'm going to call it m times n. So the product in product rule refers to the argument of a logarithm. The product rule says if you have a log of a product, you can split it into 2 logs. You keep the same base, and each factor of the original argument gets its own logarithm. But here's the catch. When you use the product rule on the log of a product, you get a sum of logs. This is kind of the logarithmic version of the exponent rule that says b to the m times b to the n equals b to the m plus n. Most exponent rules have a version for logarithms. This is the logarithm version of the addition rule for exponents. There is a caveat, and most of the times it's a non-issue. Towards the end of the next series of videos, you'll see why it is a subtle issue. This is true most of the time. This is true when m, n, and mn, their product, are all positive. And if they're variables, we usually work under the assumption that they're going to be positive. But the reason that caveat is necessary is it's possible for this product to be positive, but both of its factors could be negative, such as -5 times -4 is positive 20. A positive 20 here would be okay, but over here a -5 and a -4 would not. You really won't have to worry about that caveat, but towards the end of the next series of videos, the fact that it's there will show you why we have to do a certain something. I don't want to give it away, so for now, don't worry too much about it, but later it will become something worth discussing. So how does the product rule work on just a simple logarithm, such as log of 1 million x, or log base 3 of 9 times 5? Well, it simply says if you have a logarithm of a product, you may split it into multiple logarithms. Each factor would get its own logarithm. In this case, 1 million x has 2 factors, 1 million and x. So the 1 million would get its own log, the x would get its own log, and the product rule says that the log of a product equals the sum of logarithms. If you really wanted a whole sentence, it would be the log of a product equals the sum of the logs of the product's factors. So each factor gets its own log and you take the sum. Now, I pulled this one directly off the homework. This was my version of number 1. Yours will be similar. It might actually be this one, but it probably won't be. When you expand a logarithm like this, in the sense that the expression contains more logs than it used to, you should be on the lookout for logarithms that you can answer easily. For example, log of 1 million, we can get an answer to, and we really don't even need a calculator. Although your calculator should have a log button on it. When you see log without a base, do you remember what base that implies? It implies base 10. So anytime you're about to answer a problem like this, and you see a logarithm of a number, you should think to yourself, so I'm thinking over here, do I know the answer to this? Or can I find the answer to this relatively easily? And because we're going to be thinking about the question a logarithm asks, I'm going to write its implied base of 10. And this logarithm is asking what power do you put on 10 to get 1 million? Well, powers of 10 are easy to spot. A power of 10 is just a 1 with a bunch of zeros after it. So what power would it be? The number of zeros. The power that turns 10 into 1 million is 6, because 1 million has 6 zeros, which means that the log of 1 million, base 10 if you want to explicitly state it, is 6. So if this were a homework question, you would be expected to look at that log of 1 million and do something with it, if you can. Not all numerical logarithms have nice, convenient answers. So if this were a homework question, this would be your answer. 6 plus log of x. And you can even apply the product rule to logarithms that involve just numbers and not even variables, such as the log base 3 of 9 times 5. Now, I know 9 times 5 is 45, and we could have started it this way, but in order to use the product rule, the argument must be a product. And I can factor 45 into 9 times 5, but if you're going to ask me to use the product rule, you should at least give me a product to apply it to. If we apply the product rule to this logarithm, the product rule says the log of a product equals the sum of the logs, and you preserve the base, so these are both base 3. And each factor in the product gets its own logarithm, so 9 gets its own logarithm, as does 5. And by the way, the product rule works for as many factors as you have. For example, if I had 3 factors, we'll say m, n, and o, then I would have 3 logarithms and they would all be added. Oh, wait a minute. Both of these logs are numerical, so we should ask if we know the answer to either one of them. The answer is yes. Do you know which one we should be able to answer easily? Well, that depends. Do you know the questions they're asking? This first one is asking what power would turn 3 into 9. The second one is asking what power would turn 3 into 5. And I know the answer to the first one. The power that turns 3 into 9 is the second power. 3 to the second power is 9. The power that turns 3 into 5 is somewhere between 1 and 2. Because 3 to the first power is too small, that answer is 3. And 3 to the second power is too large, that answer is 9. If the answer is not a whole number, or in some cases is an obvious fraction, like if there's a square root, then you just leave it alone. I'm kind of curious what the homework says to tell you to do the first log but not the second. Where possible, evaluate logarithmic expressions without a calculator. Okay, that's fair. We can evaluate this with a calculator. I haven't told you how yet, but by the last video in this series, you'll know how. So the product rule is pretty easy to use. It simply says the log of a product equals the sum of the logs of the product's factors. So everybody gets their own log, but they get added together.